Properties of Fluxtrol and Ferrotron materials. Fluxtrol primary products. This chart shows the physical characteristics of primary and specialized products. Note that frequency ranges and resistivity values are only for reference. Magnetization curves for Fluxtrol products. Compared to laminations and ferrites, Fluxtrol materials are almost linear. This means that Fluxtrol controllers do not generate distortions in coil currents or voltage waveforms. Distortions result in additional reactive power of the coil and additional losses in transformer and capacitor battery. Permeabilities were measured at 10 kHz for a favorable direction of magnetic flux flow. These data remain valid for all frequency ranges specified for particular materials. Magnetic permeability of Fluxtrol products. Fluxtrol A material can support permeability above 50 at high magnetic loading, flux density up to 14,000 Gauss, which is essential for high power and low frequency applications. Range of flux density in measurements is sufficient for the majority of applications. Materials may be used even at higher load at proper conditions, short heating cycle, intensive heat removal. Permeabilities were measured at 10 kHz for a favorable direction of magnetic flux flow. These data remain valid for all frequency ranges specified for particular materials. Material anisotropy. When material has different properties in different directions, they say that material is anisotropic. Laminations are highly anisotropic because all properties in the plane of a sheet are very different than in perpendicular direction of the stack. Ferrites have low anisotropy, except in special types of material. Fluxtrol composites are pressed materials and therefore have certain anisotropy, which depends on material composition, size, and shape of particles, and manufacturing technique. Magnetic and thermal properties are higher in the direction perpendicular to pressing. Anisotropy must be taken into account in a concentrator design and manufacturing in heavy loaded applications, such as high power density, high frequency, and long heating time. Anisotropy of Fluxtrol and Ferrotron materials. Fluxtrol A has significant anisotropy due to its structure. In a plane perpendicular to the pressing direction, permeability and thermal conductivity are significantly higher. Also, losses are lower when magnetic flux flows in a plane perpendicular to pressing direction. Ferrotron 559H has low anisotropy due to higher content of binder and different material structure. Fluxtrol 50 has anisotropy in between that of Fluxtrol A and Ferrotron 559H. Anisotropy of Fluxtrol A allows this material to have an exceptional combination of high electrical resistivity, thermal conductivity, and permeability with proper orientation. Optimal orientation of material in C-shaped concentrator provides high permeability, lower losses, and good heat transfer from material to the coil copper. Optimal cutting of Fluxtrol material from blank stock. As shown in Chapter 5, for the majority of applications, permeability values above 30 to 50 do not change the controller performance. Main reasons for optimal material orientation is control of the concentrator temperature, which depends on losses,